proceed with our first topic, which is the work, energy, and power. Okay, so work, energy, and power. Okay, I think you're already familiar with these three since we are using this in our daily lives. So we are using energy and we are working, applying power. So we are using the concepts of these three in our daily lives. Though um, di natin siya masyadong napapansin, but we are using the concepts of work, energy, and power daily. So what are these? What does it mean when we say work, when we say energy, and when we say power? And how does these three difference? How can we differentiate these three? So to understand that, we'll tackle that later. But before that, let us know what are the objectives for today's topic. These are the objectives for today's topic. Okay. So at the end of the discussion, we should be able to first differentiate work, energy, and power, then solve problems involving the three, then relate work and energy using the work energy theorem, and describe and solve problems involving conservation of mechanical energy. So these are the objectives what that we wanted to attain at the end of our topic. Okay, so let's start first with the okay. So as I have mentioned kanina, we will talk about these three. So work, energy, and power. So what does it mean when we say work, when we say energy, when we say power? How does they relate with one another, and how does they differentiate, or how does they differ with one another? So let's start first with work. Okay. So when we say work, what does it really mean when we say work? So from the word itself, okay, work is the literal our literal understanding with the word work. Okay, so if we translate this, so in Tagalog it means uh, trabaho or nagtatrabaho. So okay, so when we say work, okay, so when we say work, then it means that we are doing something to an object, or we are working to an object. We're doing a task, we're performing a task, or we are doing work into an object. So how can we uh, really uh, describe the word work in a simple way? So when we say work, then there is a force, okay, a force that is able to move a certain object to a certain displacement. So when we say work in physics, work is applying force to be able to move a certain object to a certain displacement. Okay, so work is applying force to uh, applying force to be able to move a certain object to a certain displacement. So you're applying force to the object, or an object is applying force to a different object to move that object to a certain displacement, then that person or that object is doing work to that uh, object. So that is when we say work. But what is this unit or the standard unit that we are using in work, and how can we identify the work done by an object or a person to a different object? So the standard unit or the SI unit of work is in joules with the symbol of J. So this is the standard unit or the SI unit of work. And how can we determine the work done by a person or an object to a different object by using the equation of work? So by using the equation of work, which is force times the distance times cosine theta. So when we say force, it is in Newton, distance is in meter, and cosine theta. So sir, what does it mean when we say cosine theta? Cosine theta, okay? Cosine theta is the angle of elevation or inclination of the surface where you are doing work onto an object, or the angle of inclination of the medium a person or an object using to the another object. So what does it mean when we say medium used to apply to do a work? Okay, for example, I think you already saw a car, a towing car. So in towing a car, okay, in towing a car, uh, towing cars are using a medium, which is a, a chain or a rope or a metal. So they are using a medium to tow a car. So they hindi directly na yung car or yung towing car ang mag-pull ng another car, but there is a medium which they are using to tow a car. So it could be a chain or a rope or a metal. So that medium, if that medium is inclined, then the angle of inclination will use the angle of inclination on the cosine theta. Okay, so cosine theta. So force, which is in Newton, is the force applied to the object. The distance, which is in meter, it is um, the total distance covered while applying work. And cosine theta, it is the angle of inclination or the angle where the surface of the surface, or the angle of inclination of the medium used. Okay, so this is the equation to be used in identifying the work done by a person or an object to a different object. Okay, so to understand it better, we will try to use this equation in a problem. Okay, so what is the work done by an specimen carrying a bag with a weight of 12.5 kilogram walking along the corridor of the PL building for 20 meters? Okay, so there is a student carrying a bag weighing 12.5 kilogram walking along the corridor of the PL building for 20 meters. Okay, so we'll try to identify the work done by the student to the bag. Okay, So, by using the equation of force, which is work by which is force times distance times cosine theta, sir, you said you have mentioned that the force in the equation is the force applied to the object. But in this case, there is no force applied to the object. So how can we identify the force applied? So since there is no specific force applied to the object, then we will look for a different given which can lead us to the force applied to the object. And what is that given? That is by the, since the student is carrying the bag, so to be able to carry a bag or an object, you need to have a force which is greater than or equal to the force of the uh, exerted by the object. And what is that force? What is that force that is being exerted by the object? It is the force due to gravity, which is equal to the weight of the object. So since the weight of the object is equal to 12.5 kilogram, we can still remember during the topic on forces, the weight of the object is equal to force due to gravity. So since force due to gravity is equal to the weight of the object, then the minimum force required or applied to the object, which requires you to carry a bag, is equal to the force due to gravity, and that is equal to 12.5 Newton. Sa 12.5 Newton lang ba ang aming gagamitin? So since hindi natin alam ang specific force applied to the object, then we will use the minimum force required to lift a bag or to lift an object, which is equal to the force due to gravity and also equal to the weight of the object. And that is equal to 12.5, which in this case is now a force, which is now a force. Then the unit we'll be using is in Newton. So the force due to gravity or the force applied is equal to 12.5 Newton. Then we also have the distance, which is equal to 120 meters. Okay. So how about the cosine theta? So cosine theta, so as I have mentioned kanina, it is the medium used to the object or the surface where the object is residing. So since in this case, there is no medium used, so therefore, the angle is, the cosine theta or the angle theta is, um, since there is no medium used and the student is walking along the corridor, okay, since the corridor is parallel to the surface, parallel to the ground, or it is horizontal, if the medium or the surface is parallel to the ground or horizontal, then the angle theta or cosine theta is equal to 0 or cosine 0. So, complete the equation, we'll have 12.5 Newton, which is the force applied, then 20 meters, which is the distance, and cosine 0, which is the angle of inclination. So if we input cosine 0 in calculator, it is equal to 1. So 1 times 20 times 12.5, that is equal to 250 joules. Since the least number of significant figure we have is only 1, which is in 20 meters. So round this to one significant figure, that is equal to 200 joules. So therefore, the um, the work done by the student is equal to 200 joules. So that is the work done by the student. Okay. So sir, what are some example which angle theta has a value? Okay, so this is an example which angle theta has a value. So what is the work done by a physician in carrying a bag with a weight of 12.5 kilogram, but this time the student is climbing the spiral staircase from ground floor to fourth floor. If the distance between floors is 5.0 meters and the angle of inclination of the staircase is 28.0 degree. So this time, the same student, the same object, but different situation. Okay, so this time, the student is climbing the spiral staircase from ground floor to the fourth floor. So using the equation of work, work is equal to force times distance plus cosine theta. The same force, since walang specific applied force, so we will still using the minimum force required to lift a bag, which is equal to 12.5 Newton. So the same yung kanina. But this time, the distance, since the distance between floors is equal to 5.0 meters, when we say distance between floors, that is the distance between the first floor to second floor. That is 5.0 meters. So the distance between second to third is another 5.0 meters. From third to fourth, that is another 5.0 meters. So if we count the distances, so from ground to second, that is 1. Second to third, that is 2. And third to fourth floor, that is 3. So there are 3 distances. So if we multiply this by 5.0 meters, that is equal to 15 meters. So the total distance is equal to 15 meters. Since the angle of inclination is equal to 28.0 degree, so we will use this as our angle theta. So substitute. So 12.5 times 15 times cosine theta. So if we input this in our calculator, we can have the value of 165.55 and so on joules. So since the least number of significant figure is only 2, so round this to 2 significant figure, and that is equal to 170 joules. Box loaded with tuna, so the total mass is 50.0 kilogram. The fisherman exerts a force of magnitude which is 1.20 times 10 to the power of 2 Newton on the box by pulling on the rope. So to a distance of 10.0 meters. So we have question A and question B. For question A, how much work does he do on the box if the rope is horizontal to the ground? Okay, so same with okay, for the distance, given naman ang distance na 10.0 meters, and for the angle theta, since in this case, so the distance is 10.0 meters. For angle theta, since in this case, uh, the fisherman is using a medium, which is the rope. So since he is using a rope, and the rope is horizontal to the ground, then therefore, angle theta is equal to 0. Okay, so dito tayo sa force. Okay, some of you are using 50.0 kilogram as its force, and meron ding gumamit ng 1.20 as its force. So, saan ba dito ang pwede nating magamit talaga? Okay. So, unlike with the question kanina, yung sa bag, so dun sa bag, there is no specific force exerted. So, wala siyang applied force. So, we use the 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 weight of the bag to identify the minimum force applied to the bag. But this time, since the fisherman is exerting force to the box, which is 1.20 times 10 to the power of 2 Newton, so therefore, there is a specific applied force that is being exerted to the box, and that is the 1.20 times 10 to the power of 2. So since ito yung applied force, so ito ang gagamitin natin as force for the work done. So applying 1.20 times 10 to the power of 2 Newton times 10.0 meter, which is the distance, times cosine 0. So that is equal to 1,200 joules. So in 1,200 joules, so since the least number of significant figure we have is 3, so we will convert this to 3 significant figure. Sir, 1,200 is only 2. Paano ba natin para para mag para maging 3 significant figure siya? So we will convert this to scientific notation para mas we can express this into 3 significant figures. So convert to 1, 2, 3. It is now equal to 1.200 times 10 to the power of 3. Since 1.200 is 4 significant figures, so kunin natin yung isang 0. So magiging 1.20 times 10 to the power of 3. So our final answer is now equal to 1.20 times 10 to the power of 3 joules. Sir, bakit siya naging ganyan? Okay. So following the rules in significant figure, the least number is 3. So we need to answer it into 3 significant figure. So sir, kailan ba namin gagamitin ang scientific notation and yung hindi scientific notation? If you cannot express your answer into the number of significant figure required, then you can express it into scientific notation. But if you can, then use so pwede na hindi mo na i-convert to scientific notation, which in this case, we cannot express 1,200 into 3 significant figure. So that's why we convert this to scientific notation. Okay? So I repeat, bakit hindi natin ginamit si 50.0 kilogram? Because there is a specific force applied to the object, which is the force exerted by the fisherman, that is to the box, or the pulling force, which is equal to 1.20 times 10 to the power of 2. It's the same with letter B, but this time the angle, the rope used is elevated or inclined by angle theta, which is 30.0 degree. So substitute, that is equal to 1039.23 and so on joules. Then round to 3 significant figures, since the least number is 3 significant figure, that is equal to 1040 joules. So afterward, we will proceed with the next, which is the energy. Okay, so energy and work are related with one another. So they are related with one another. They are connected. So work and also work and energy has the same unit, which is in joules. So they have the same unit, which is in joules. So sir, bakit mo nasabi that work and energy are connected with one another? So work and energy are connected because energy serves as the fuel to do a work. Okay, energy serves as the fuel to do a work. Okay, so energy serves as the fuel to do a work. So it is the same with um, a car. So for example, a car cannot uh, uh, run, so hindi tatakbo yung sasakyan if there is no fuel that would give uh, the car energy to work. So it is the same concept with work and energy. A person or an object cannot do a work or a certain work if it lacks energy because quantity needed to perform a certain task. So energy is the quantity needed to perform a certain work. Or in short, energy is the fuel to do a work. So there are two types of energy, the potential energy and the kinetic energy. So if we combine the potential energy and kinetic energy of an object or a person, that is the total energy of that particular person or object. So when we say potential energy, okay, it is the energy of an object in which it can be used or it could be used if the object um, will start to do a work. So sa madaling sabi, pwede nating sabihin that the potential energy is an energy of an object at rest. So since it is at rest, so there is a stored or a reserved energy which um, energy na kanyang gagamitin when the object will start to do a work. And if the object is at full rest, okay, if the object is at uh, fully at rest, then the potential energy of the object is at its maximum. So when we say it is at its maximum, then for example in this illustration, okay, so in this illustration, for example, the total energy of the object is equal to 100. Okay, so if the object is at fully at rest, okay, fully at rest, then the potential energy will reach its maximum, which is equal to the total energy, and that is equal to 100. And if the potential energy is at maximum, then the kinetic energy is equal to 0 since the object is currently at rest, so it is not moving or it is not uh, doing a work, then the kinetic energy is equal to 0. And since the potential energy is a stored energy or it is a reserved energy that can possibly be used if the object will do a work, so if the object will start to move or the object will start to do a work, then that potential energy can be converted into a kinetic energy. So the potential energy will be converted into kinetic energy once the object will start to move or the object will start to work. So if the object will start to move, then dahan-dahang tataas ang kanyang kinetic energy. So dahan-dahang tataas ang kanyang kinetic energy. And since kinetic energy is a converted energy from potential energy, so if the kinetic energy will suddenly increase, so the increase in kinetic energy is also equal to the decrease in potential energy. So since nag-increase yung kinetic energy mo or yung kinetic energy ng isang object, then that increase in the kinetic energy is also equal to the decrease of the potential energy. Since potential energy is a converted energy from at rest to moving or to the object which is doing the work. And if the moving object reach its maximum speed or maximum velocity, okay, if the object will reach its maximum speed, then the kinetic energy is also at its maximum. So kung aabot na siya sa punto na the object will reach its maximum speed, then ang kanyang kinetic energy is also at maximum. So if the kinetic energy is at maximum, then the potential energy this time is now equal to zero. Since yung potential energy is already converted to kinetic energy, then the potential energy will now become zero if the kinetic energy will reach its maximum energy. But the maximum of both potential and kinetic energy will never exceed the total energy. So kung ano yung total energy ng isang object, yan din yung possible maximum energy on both potential and kinetic energy. Since total energy is a combination of potential and kinetic energy. So sir, what if the potential energy is already um, converted to kinetic energy? Hindi na ba siya babalik into potential energy? So, the kinetic energy, okay, the converted kinetic energy will return into potential energy if the object will start to slow down. So, kung mag-slow down na yung object, okay, for example, as it reach its maximum speed, then nagdahan-dahan siya nag-slow down, then if the object will if nag-slow down na yung object, then the kinetic energy will decrease. So if nag-slow down yung object, mag-decrease na yung kanyang kinetic energy, and it will converted back into a potential energy. So if magbaba yung kanyang speed, magbaba rin ang kanyang kinetic energy, which will return into a potential energy. So that is the relation or the um, relation of potential energy and kinetic energy, which we call a conservation of mechanical energy. So we have both the potential and the kinetic energy, which is equal. So we have both potential and kinetic energy, which is equal to the total energy. So yun lang ang always remind natin that from potential energy is the energy at rest. So if the object will start to move, then tataas yung kanyang kinetic at bababa naman yung kanyang potential energy. And when the object will slow down, bababa yung kanyang kinetic energy and tataas naman ang kanyang potential energy. And that is the reason why I have mentioned that potential energy and kinetic energy are inversely related with one another, because if potential will increase, the kinetic will decrease. The same with, if the kinetic will increase, the potential will decrease. So that is the conservation of mechanical energy. So paano ba natin malalaman yung potential energy na isang bagay or ng isang tao? How can we determine its potential energy? So in determining the potential energy of a person or an object, then we will use the potential energy equation. Ano ba tong equation na to? So that equation is potential energy is equal to mass, which is in kilogram, times the gravity, which is the constant 9.81 meters per second square, times the height of the person or the object, which is in meters. So mass, which is in kilogram, gravity, which is 9.81 meters per second square, and height, which is in meters. So that is how to determine the potential energy of a person or an object. So let's try to use this equation. Okay, the potential energy of a person, which is 5.0 meters above, okay, above the ground, is 1,295 joules. Okay, what is the mass of the person? Ano daw yung mass ng isang person which has a height that is equal to 5.0 meters, and its potential energy is 1,295 joules. Okay, so using the equation of potential energy, so mass times gravity times height. So the potential energy is 1,295. The mass is unknown, gravity, which is constant, and the height, which is 5.0 meters. So if we multiply the gravity and the mass, that is equal to 49.05. Okay. So next is to divide both sides by 49.05 to retain mass. So if we divide 1,295 by 49.05, that is equal to 26.4016 and so on kilogram. So since the least number of significant figure we have is only 2, so we round this to 2 significant figure, and that is equal to 26 kilogram. So therefore, the mass of that person is equal to 26 kilogram. Okay? So that is the mass of the person. Okay, another example, if the height is missing. So the height, what is the height of a 500 grams be at potential energy with 150 joules, and we are looking for the height. So using the equation, so since mass is in kilogram, okay, so since yung mass is dapat kilogram, so we need to convert first 500 grams to kilogram. So convert this to kilogram, that is equal to 0.5 kilogram. So the gravity is 9.81, then the potential energy is 150 joules. So 0.5 times 9.81, that is 4.905. Okay, next is to divide both sides by 4.05. So ang maiwan dito is si height na lang. Then 150 divided by 4.905, that is equal to 30.58103 and so on. Okay? So next, since the least number of significant figure is 1, then we round this to one significant figure, and that is equal to 30 meters. Object. So this time we will know how to solve or to identify the kinetic energy of a moving object. So how can we do that? By applying the equation of kinetic energy, which is equal to 1/2 of its mass times the square of its velocity. So since kinetic energy is the energy of moving object, then since it is moving, then therefore a it has a velocity, or it has a speed. So kinetic energy is equal to 1/2 of its mass, which is in kilogram, times the square of its velocity, which is in meters per second. So this is how to identify or to solve for the kinetic energy of a moving object. Okay, so let's try to use this equation in a given problem. So we have here, the kinetic energy of an electron is found to be 2.38 times 10 to the power of negative 15 joules. So we have the kinetic energy of the object, which is 2.38 times 10 to the power of negative 15 joules, which is the electron. So at what speed? So ano daw yung kanyang speed or yung kanyang velocity? Is the electron traveling? So anong speed ng ang electron while it is traveling? If the mass of an electron is equal to 9.11 times 10 to the power of negative 31 kilogram. So we have here the kinetic energy and the mass. So we are looking for the speed or the velocity of the electron. So using the equation of kinetic energy, which is 1/2 times mass times the square of its velocity, substitute the given. Okay, so we have here, so 1/2 of 9.11, that is equal to 4.56 times 10 to the power of negative 31. Okay, so after we multiply, we divide both sides by 4.56 times 10 to the power of negative 31. Para maiwan na lang is the velocity. So velocity square. So 2.38 times 10 to the power of negative 15, that is equal to 5.219298246 times 10 to the power of 15. So since the velocity is in square, so we will apply square root on both sides para to eliminate the square of our velocity. So applying square root on both sides. So square root. So the square of v square, that is equal to v. Then the square root of 5.219298246 times 10 to the power of 15, that is equal to 72,244,710.85. So that is the square of 5.2192 times 10 to the power of 15. And since the least number of significant figure we have is only 3 significant figure, so we will round this to 3 significant figure, and that is equal to 72,200,000 meters per second. And that is the velocity of the electron while traveling if the kinetic energy is equal to 2.38 times 10 to the power of negative 15. Okay, so that is the kinetic energy. So let's try another example. So what is the kinetic energy of a 2,793 kilogram car? So we are looking for the kinetic energy. If the mass is given, which is equal to 2,793 kilogram, and the velocity is equal to 8.3 meters per second. So using the equation of kinetic energy, we'll substitute the mass and its velocity. Okay, so 8.3 square times 2,793 times 1 half. Okay, that is equal to 96,204.885 joules. So since the least number of significant figure we have is only 2, so round this to 2 significant figure, that is equal to 96,000 energy. So now let's proceed with power. So power, which has a unit of watts. So the unit of power is watts. So ano ba tong power? Since I have mentioned that work and energy are related or connected with one another, since energy is used to do a work. So since energy is used to do a work, or kumbaga ito yung fuel niya to do a work, or ito yung fuel to do to move the object. So ano ba ang relation, or ano ba ang connection ng power to work and energy? So, but before that, let us first know what is power. So power, when we say power, it refers to how fast something is able to do a work. So when we say power, it refers to how fast, okay, how fast an object can do a certain work. So, baga, it is, when we say how fast, then therefore, it has a time, um, given, or it has a time interval. So, may time interval siya to do a certain work. So, kung mas malaki yung power ng isang object, then much lesser din ang kanyang time interval to do a certain work. So, therefore, we can say that power, okay, we can use power as a reference, okay, as a reference to choose a proper object, or to choose an appropriate object to do a certain work. Because, as I have mentioned kanina, the greater the power, then mas mabilis rin yun ang kanyang, okay, so if an object has a greater power, then it can do a certain work with much lesser time interval. So kung mas malaki yung kanyang power, then mas mabilis rin uh, ang kanyang pag to do the work. But if mas lesser yung kanyang power, then mas mataas rin yun ang kanyang time interval. So therefore, then that's how can we connect power with work and energy. So since energy is used to fuel the object to do a work, then power naman is referring to how fast an object can do a certain work. But how can we determine the power of a certain object? So to determine or to know the power of an object, then we will use the equation for power, which is power is equal to work over time. So work over time, since there is a time interval given. Okay, so since there is a time interval, And time in power, okay? So the unit for time is in seconds. So the unit in time is in seconds. So seconds. So since we are dealing with work over time, so if work is not directly stated, then we can use or we can substitute the equation for work as a substitute in the work, as a substitute to the work in the equation of power. So ano ba yung equation ng work? Force times distance times cosine theta divided by time, which is in second, so that we can identify the power of a given or an object. So that is how to solve or to know the power of an object. So if the work, okay, if the work done is not stated, so if it's not directly stated, so we can substitute the the equation for work as a substitute for the work in our equation in power. So power is equal to force times distance times cosine theta divided by time. So let's try to use this equation in a given example. So I have here, so I think you are familiar with this example. Since this is an example that we have uh, answered during the discussion on work. So what is the power of a specimen carrying a bag with a weight of 12.5 kilogram walking along the corridor of the PL building for 20 meters for 3 seconds. Okay, so the distance is 20 meters. The time interval is in 3 seconds. Okay, so since the corridor is horizontal, so angle theta is equal to 0. And the force applied, so since hindi um, binigay yung kanyang specific applied force, so we will use the minimum force required, which we already discussed during work. So F times D times cosine theta divided by time. Force is equal to 12 Newton, which we already explained last during the work. Then the distance is equal to 20 meters. And cosine theta, theta is equal to 0 since it is along horizontal or parallel to the ground. Then time interval is equal to 3 seconds. So if we multiply 12.5 times 20 times cosine 0, that is equal to 250 divided by 3, which is the time interval, and that is equal to 83.333 watts. And since the least number of significant is only 1, so round this to one significant figure, and that is equal to 80 watts. So the power used by the student is equal to 80 watts. Okay, so it's the power used by the student. Okay, another example is, okay, so this time he is climbing the spiral staircase from ground floor to fourth floor for about 1 minute. So since the time interval given is in minute, so we need to convert first minute into seconds. So the distance between floors is 5 meters. And the angle of inclination of the staircase is 28.0 degree. So using the same force, which is 25 Newton, at 12.5 Newton. So the converted time is 60 seconds, since 60 seconds is equal to 1 minute. And the distance is equal to 15 meters, which is 5 meters times 3 floors, which is the 3 floors interval. So 12.5 times 15 times cosine 28, that is equal to 165.5526737 divided by 60 seconds, which is the time interval, and that is equal to 2.7592112228. And since the least number of significant figure is only 1, so round this to one significant figure, and that is equal to 3 watts. So the power